Assalamualaikum and hi to all. Okay, this video we're going to cover on our 8.5 benchmarking and also 8.6 summarization, because I guess this video is only not even 10 minutes because it's just related to a theory, the definitions about all the things that you need to learn, which is where pen. It's my pen. Okay, over overall, then you need to learn on cloud red. What is the cloud red? What is the definition? MIPS, flop, synthetic benchmark, spec benchmark, TPC benchmark, system simulation. So in this submodule, which is under benchmarking, there is no more equations that you need to memorize. So it is more on theory, on the meanings, and also the understanding of all the terms. I guess it's very like short and simple. So let's proceed. So about benchmarking, when you first heard about benchmarking or benchmark, so you know that there is some things that okay, it will stop there. So the benchmark is, let's say, the benchmark for a student at UTM, certain benchmark. So let's say if you did not meet that benchmark, you cannot be a UTM student. So that's simple. So benchmark is the most common approach to assessing super processor and computer system performance. Performance benchmarking is the science of the making objective assessment of the performance of one system over another. So you need to have at least more than one system. Benchmarks are also useful for assessing performance improvement obtaining by upgrading a computer or its components. So there is advantages of the benchmark, which is enable to cut through advertisement type and also statistical tricks. Second is identify the system that provide good performance at the most reasonable cost. Okay, now you look into all of these, which is under clock red, MIPS, and flop. CPU speed is a mislead metric that is most often used by computer vendor touting their system alleged superiority to all another. So widely metric related to clock red is MIPS. So everything that related to clock red normally it's known also MIPS. Let's say for the example, saying that system A 1.4 gigahertz. So this one is, you know, this is red, this is frequency, is faster than system B 900 megahertz. Is valid only when ISA of system A and B are identical. So let's say you already identical the system A and system B, and then it is valid. With different ISA, it is possible that both of the system could obtain identical result within the same amount of wall clock time. Okay, I just give you example like in our day-to-day life. Whatever, let's say you want to okay, on computer. Let's say I am using Microsoft Words. I am using Windows. You also using Windows. So we try to run Microsoft Word, but mine laptop is Acer, Your laptop is Lenovo. We have several several some similar system, like we are using Windows 10 together. Our processor is similar, our RAM is similar, all the thing, our system is similar. So we are in a similar system. Only the difference between the different device only. Everything else is similar. So whenever you want to compare anything, it is a valid things because we did similar things. But let's say I am using Acer, you are using Lenovo. Our system is similar, only that I didn't I didn't use Microsoft, which is Windows, right? I am using Linux. So our open source is our platform is different. So with different ISA, let's say, so when we try to compare a Linux and also Windows, it's going to totally different. So different ISA, it is possible that both of these systems could obtain identical result within the same amount of all clock time. This is similar problem with the flop metric. What is the flop metric? Flop metric is even more difficult than your MIPS metric because there is no agreement as to what constitutes floating point operations. Despite their shortcoming, like your clock speed, your MIPS, and flops can be useful metric in comparing relative performance across a line of similar computers offered by the same vendor. Same vendor is basically kalau HP lah, kalau Acer lah. And it's also compare the similar computer. Only in terms of performance, of course it's going to be different. Although it is a different, although it is a similar computer, you're not going to get similar things. This is happen in our real life wherever you will do anything in our experiment. So scientific benchmark, you're going to know about whetstone, line pack, Dranstone also. The result execution time will lead to a single performance metric across all the system tested. So scientific benchmark, synthesis benchmark, because they don't necessarily represent any particular workload or applications. So the disadvantages, these programs are much too small to be used in evaluating the performance of today's system, because our today's system is nowadays very complex. Three of the better non synthetic benchmark are the Whetstone, Linpack, and also Grindstone metric. So this is a three benchmark under our synthetic benchmarks. Our spec benchmarks are trying to evaluate the standard performance evaluation cooperation. So this is the meaning of spec. The science of computer performance measurement benefits greatly by the contributions of the Whetstone, which is our synthetic benchmarks, Linstone, and also Drystone benchmark. For one thing, this program gives merit to the idea of having a common standard benchmark should by which all system will be compared. Dalam semua sistem, when you have a lot of system, you can compare it using our standard performance evaluating corporation benchmark. Their most widely known benchmark shoot is CPU shoots. Okay, so under spec there is a CPU shoot. The latest version of this benchmark is CPU 2000. Consists of two parts, which is CINT 2000, which is measure integer arithmetic operations, and another one is CFP 2000, which measure floating point processing. So you need to like memorize all the informations related to spec, related to our synthetic benchmark, and also another one is our clock rate, MIPS, and also flop. What is MIPS? MIPS is millions of instruction per second. So ISA over here also is already given, which is instruction set architecture. Another one is under TPC. TPC benchmark, which is also the long name is Transaction Performance Council. Spec benchmark are helpful. Several previous slide it already shows it's very helpful to computer barriers whose principal concerns is CPU performance. When the performance of the entire system under high transaction load is a greater concern, the TCPC benchmark are more stable because you already look like your scientific benchmark also it cannot be used like a complex system, and a spec also didn't support that. So the most suitable benchmark module or techniques for the higher transaction load is using TPC benchmark. The current version of shoots of TPC, which is TPC-C benchmark, and this module, the transaction typical of warehousings and also distribution business using terminal emulation software. This is our, this is another benchmark scheme. And lastly is our system simulation. Our system simulation, the TPC benchmark differ from our spec benchmark in that they try to simulate a complete computing environment. Although the purpose of the PC benchmark is to measure performance, their simulation environment may also be useful to predict, hence optimize performance under various conditions. So you can doing it on several type of conditions to just check the performance. In the general, simulations give us tools that we can use to model and predict aspect to system behavior without the use of the exact live environments that simulator is modeling. So let's say you are doing project, any kind of project for your final year project also maybe. So before you can develop something, you need to do a simulation. Of course, similar also like okay, if you want to be a pilot, you need to learn how to drive the airplane, right? Aeroplanes, using a simulator project, a simulator software, and so on. Because before you go to the real things, you need to master and also try implement it in a simulations. Similar also, let's say you have several other project or system, you will do the simulation before you can apply. Let's say kalau in term of okay lah yang paling bahaya, let's say electrical, let's say electric or also mechanic, chemical. Before you campur you going to add carbon dioxide ke, I don't know about this, but this is an example. so that you can understand. Let's say you have the oxygen, and then you add with the carbon dioxide. Before you can pour all the liquids together or the gas together, you need to doing the simulation first. Rather than tiba-tiba when you tambahkan both liquids all together, then tiba-tiba meletup. It is also similar, like if let's say you are applying in electronic things. Before you can putting all the jumper wire here and jumper wire there, where you need to put the capacitor, what is the value for the capacitor, and then the voltage, before you can apply it into the real elements, into the real device. You need to run the simulation first, whether it's work or not. If it is not work, maybe the circuit is burn, is okay, but how come is, let's say, tiba-tiba meletup kan. So that's why system simulations is one of important scheme, especially when you want to apply into a system, and if let's say you want to check the performance also in term of the system. Not only like you apply in a real environment, but when you want to check also performance also, you can use the simulation. So that's all on the schemes. So we can summarize it on our 8.6. Computer performance assessment relies upon measures of central tendency that include the arithmetic means. This one we already learned, and also another one we look what geometric mean, right? And then wastage arithmetic mean, this one also we already look into the value, the geometric mean, and the harmonic mean. Each of these applicables under different circumstances, and benchmark should have been designed to provide objective performance assessment. The most well respected of these are the Spec and also TCPC benchmark. CPU performance depend upon many factor, because you can check many factor in terms of different kind. Sometimes your computer is good in the RAM, but your storage is smaller. So any kind of factor. This include the pipeline, parallel execution unit, integrated floating point unit, and effective branch prediction. User code optimized afford the greatest opportunity for performance improvement. Code optimization methods include loop manipulations and also good arithmetic design. So there is several exercise you can try to do it, but it is not too hard, especially in calculation. It's more to mathematical, so I hope that you can try to do it. So I guess only that for our module 8. We already cover all. If there is any question, you can ask me in class, and also you can try to WhatsApp me. Okay, thank you for your watching, and please stay at home and be safe. Bye bye.